Hello, this is Hui. Welcome to watch my video, C++ Programming on Linux. In this short video, we are going to discuss another very important topic of OpenSSL, the digital certificate, also known as a public key certificate. A public key certificate, also known as a digital certificate or identity certificate, is an electronic document used to prove the validity of a public key. The certificate includes information about the key, information about the identity of its owner, called the subject, and the digital signature of an entity that has verified the certificate content, called the issuer. There are a few standard certificate formats. In this short video, we are going to use X509 certificate as an example. X509 is an International Telecommunication Union standard defines the format of public key certificate. X509 certificates are used in many Internet protocols, including TLS, SSL, which is the base of HTTPS. Industry introduced the digital certificate in order to prevent a common security issue called man-in-the-middle attack. In web application, the client and the application server communicate through the Internet. Such infrastructure can cause a man-in-the-middle attack, which is a man-in-the-middle can redirect original connection goes through him. So, in the middle, he can steal sensitive information or making malicious operations. Here is a general procedure how to apply a digital certificate. Mario Rossi would like to apply a digital certificate. He creates a certificate sign request, CSR, include the message of identity of Mario Rossi and the public key of Mario Rossi. Certificate authority verify the identity of Mario Rossi and encrypt with its private key. So the certificate of Mario Rossi has the identity of Mario Rossi, public key of Mario Rossi, and the digital signature of certificate authorities. This certificate we call the public trust certificate, usually used for the public-facing applications. Certificate authority uses the charge client for issue public certificate. In this short video, we are going to create a self-signed certificate, which we create a certificate and we sign ourselves. Self-signed certificate will not be trusted for public-facing application. They are mainly used to encrypt and authenticate data within the organization's network. Here on the Linux, first we edit our certificate class x509_certificate.h and x509_certificate.cpp. First, we create a class called my_x509_certificate. In this class, we have a default constructor and we have two private members. One is called the pointer of certificate p_x59. One is the pointer of evppk. For the ppk, we have three methods: generate rs key, which generate rs key object; save pk, save our pk object to a key file; load key method, load key from the key files. These three methods are copied from previous videos example. Three methods: generate x59, generate x59 object; load x59 certificate, where load x59 object from the certificate files; save x59 certificate, where save x59 object to certificate files. Here is our implementation. First is a default constructor. Assign the certificate pointer and the pk pointer with non-ptr First method, generate RS key, generate RS EVPPK, and update PPK. The input will be the key bits. Return will be the pointer of EVPPK. This method is copied from previous video's example, so we just fast skip this method. Second method, save PK, save EVPPK object to the key file. If isPrivate is true, save to the private key file. False, save to the public key file. And the key file is the file name we're going to save to. This method also copied from previous video, so we just fast skip this. Next method, load key from the key files. Key file, the file that load from. If isPrivate is true, we load from private key file. False, load from public key files. This method is also copied from previous video, so we just skip this. Method, generate X509. Generate X509 certificate object and EVPPK. Input is a key bit. Return will be the pointer of X509 certificate object. First, we declare variable return code, and we're going to check if px59 is not non-pointer. It means x59 certificate has already generated or loaded. So we just return pointer, which is the object we have already generated and loaded. After that, we check our pk. If free the memory we allocated before, then we call the method generate RS key to regenerate new ppk. Parameter will be the key bit. Return pointer of EVPPK object we generated. After that, we first instantialize and allocate memory for X59 object. Function called X59_new. Return is a pointer, which is the object we instantialized. The general structure of X59 has version number, serial number, validate period, not before and not after, subject name, which is the owner, issuer name is the signers. For the self-signed certificate, subject name and the issuer name should be the same. First, we set up version number using the X59_set version certificate and 1. Second, we are going to set up the serial number. We get our pointer and we sign this with 1 using the ANSI integer set. Next, we will set validation period. We can use 2 functions, X59 time adjust, X59 GM time adjust. In this short video, we use X59 GM time adjust. First, we adjust not before using X59_get_not before, get the internal pointer, offset is 0, which is not before from current time, and the time not after, 1 year after current time. This number equals 365 times 24 times 60 and times 60. After we finish adjust the time period, we're going to adjust the subject name. So we instantialize empty X59 name object, p name. For our subject name, we first add C, CA country, ST, Ontario, locality, Toronto, O, organization name, my company, OU, my department, CN, command name, local host, and my issuer's name. Since it's a self-signed certificate, subject name and the issuer name should be same. So we use the X59 set subject name, p name, and the X59 set issuer name and the same p name. After that, our certificate needs to have key information. So we use the X59 set public key, certificate, and the public key. After we set out all this information, we can actually sign the certificate with the key and algorithm. Function is called X59_sign, 3 parameters, certificate, key, algorithm. If RC less or equal 0, it means our sign failed. Otherwise, the RC will be the length of the signature. So we just print out signature length RC, and we return our pointer of certificate object. Next method, load X59 certificate. This method will load X59 certificate from certificate file to px59, extract public key to pk. Input X59 file, return will be the pointer of X59 certificate. First, we declare pointer bio underscore X59 using bio underscore new underscore file name from method parameter. For reading, return is bio underscore X59. If px59 is not equal non-pointer, it means our certificate has already generated or located or loaded. We have to free our certificate. Use the X59 free. Parameter is px59. And then we start loading using PEM read bio X59. Read from bio. Return is the pointer px59. Now we free our BIO. If px509 is equal non-PTR, it means read BIO function got error and we return none. It means we not successfully loaded. And after that, we extract public key from the certificate and update PK pointer. After we have a certificate and the PK, we can use X509 underscore verify to verify the certificate and the public key a match or not. We can also verify time period, not before and not after. But in this short video, to keep example simple, we just do one verify. Next method is a save X59 certificate. Where save X59 certificate object to the file. Parameter, file name, and return. 1 is a success, 0 or negative is a fail. So first we declare variable, return code, and pointer for BIO out. If px59 equal non-PTR, it means certificate object has not been generated. We just print a message, return -1. We instantialize object using the bio underscore new underscore file name from the parameter of method. Writing return is the bio out. Then we can use the PEM write bio underscore 509 function, write to bio our certificate. Return code not equal 1, it means we are writing to bio failed. If success, we just free our BIO and return our RC. Next method, destructor, we just free our memory allocated for the certificate object. Free the memory we allocated for EVPPK object. Now we save our program. We're going to create 3 applications. One is called generator x59.cpp, display underscore 509.cpp, verify x59.cpp. The usage for generator x509.cpp, first argument key bit, second argument will be the x59 file name, third argument will be the private key file name and the public file name. We declare some variable, my x59, my key bits, and the integer return code. After validate the syntax, we first get my key bit. First, we convert argument 1 to my key bit. Next, we initialize certificate object. We name it x59 obj. Then we generate certificate using the method generate x59. Parameter will be the key bit. If my x59 is non-pointer, it means generator failed. Then we print out error message. Else, success. So we copy this line. After we generate our certificate object, we're going to save our certificate. So rc equal method is called save X59 certificate. Parameter will be the file name from the argument 2. If rc not equal 1, it means failed. Copy 2 line. Save X59 certificate error. Next, save our private key method. Save pk. First, the file name will be the argument 3, and it's a private key. Second parameter will be true. 1, 2, 3, 4. So 4 line copy. If return code not equal 1, save private key error. Next method, rc equal and rgv4 copy this 4 line. Save public key errors. And we just finished our program, generate the RS key. Second application will be the display certificate, which we load certificate from file and we display the certificate informations. So first, we declare variable is pointer of our certificate, and after we verified syntax, we're going to instantialize certificate object. We name is X59 obj. We use the method load X59 certificate. Parameter is a certificate file, will be argument 1. If my X59 is non-pointer, it means we load certificate file error. So we just print out message. After we load it, we just print our certificate information. The function called first parameter stout. The second parameter will be my X59. Then we return. So now we save this program. Next program, verify X59. The usage first argument is the X59 file and certificate public key files. So we are going to verify our certificate public key files. First, we instantialize our certificate object. We name is X59 object, and we load our certificate. My X59 equal file name from the argument 1. If my X59 equal non-pointer, it means load certificate error. Print out message. After load the certificate, we're going to load pk. My pk load the key, and the parameter will be the key file from argument 2, and it's a public key, so it's false. If my pk equal non-ptr, which means we load public key file errors. After we load both certificate and public key, we can verify using equal first parameter my X59, second parameter is my pk. If rc not equal 1, it means verify error, otherwise success. Finish our program. Now we save our program and we compile. Now we compiled. This is our executable. First, we generate X59 certificate. So usage will be 2048 is a key bit. Certificate file called my X509.pm, my private key.pm, and my public key.pm. Generate a certificate success. Signature length 256. So this is a 3 PM file, certificate, public key, and the private key. To display, the usage will be the display and certificate file name. Here is the certificate information. Version is 1, serial number is 1. We use an SHA 256 algorithm. We use an RSA encryption, and our issuer, our validated period from current to 1 year later. Subject name and the issuer name will be the same. Here is our public key algorithm. The RSA encryption key bit is 2048. Here is the public key module, and here is the signature algorithm SHA 256 RSA encryption, and here is the signature module. We verify our certificate, the my X509.pm with public key. Verify success. This example can also be performed through OpenSSL command line. The command will be the REQ X509 SHA 256 period 365 new key RSA 2048 key name and the certificate out. Now ask the country name, the CA, the state name, Ontario, location name, organization, this local host. So now we generate our new certificate. We generate our API private key and the API certificate. To extract public key from private key, the command pkey. So we call the API public keys. So we have a API generator private key, API generator public key, API generator certificate. We have our program generator public key, our program generator private key, and our program generator certificate. To display API generator certificate, here is using OpenSSL API generator certificate information. Verify API generator certificate with API generator public key success. If we verify API generator certificate is our program generator public key, verify errors. So this is the certificate look like. Begin certificate and the certificate, and here is all the information. Private key we generated. This is the begin private key and the end private key. This is all our private key. And this is our public key. This is begin public key and public key. Hello, this is Hui. Thanks to watch my video. Hopefully this is useful, and it's going to be great to have your feedback.